So here's a histogram of the box that has 2 zeros and 8 ones. So it would look like 2 zeros, 8 ones, the ones are bigger, okay? So what we want to see here is we want to see what happens, or what are the possible sums. Okay, now when we look at the possible sums, that means if we draw different times, like what if we draw 5 times, what would the possible sums look like? What if we draw 40 times, what would the sums look like? Or 400 times, what would those sums look like? Okay. Now, I don't ask you to know how to do this, and I don't ask you to draw the graphs. This is something that's at a more advanced level than what we learn in this class. But I do know how to draw them. That's okay. What you have to do is you have to be able to recognize them, okay? Because when you have, for small numbers, like, say, 5 draws, if we have small number of draws, it will still look lopsided. But if you have, say, 400 at a big number of draws, then the possible sums will look normal. That's due to the central limit theorem that says the sums, now this doesn't work for everything, it doesn't work for things like products, but the sum will always look normal if you have a big enough number of draws, which we usually say is something over 30 for most data sets. Okay, so again, you don't have to look at this and say, oh, well, that one would have to be like 5 versus 10 or something, but you should be able to say 5, 40, and 400, you should be able to pick out which one had to be which. So like this one is lopsided. So it would have to be the smallest number of draws. So the smallest number of draws is 5. This one is the most normal. So that would be the biggest number of draws. So 400. And then the last one is just 40 by process of elimination.